Test. Okay, that's on. How's everybody doing today? Oh my God, it's Friday. I can't believe it's like we're already on Friday. For me, like for most people, this is like day 3. But if you're a Treefort member, this is like day 5 because we start on Monday. But anyways, I hope you guys are all having a blast. Thank you so much for coming out to Hackfort. My name's Sean Wakely. I'm the current producer of Hackfort. I've been with this. This is our 6th year. That's Mike Taylor back there, our director. He held up the I'm so proud of his programming this year. Mike did an amazing job. But I am so stoked to introduce our next speaker. I've known Mike and I had the privilege of being connected with Dan, our first Hackfort, actually. And back then, Dan came and gave a whole talk about how he broke into buildings for a living. And, since then, he's done, you've been in the industry for a while, but I'm so excited to get an update from our friend Dan. And, enjoy, and thank you guys again. There will probably be some time for Q&A as well, so we'll pass around a microphone when we get to that point. Dan, thanks again. And there will be water coming for you, Dan, promise. Wait, no, I'm trying to pause for water, actually. I'm just kidding.
Okay.
We'll get it to you.
All right, I'm Dan McInerney. I'm the lead threat researcher at Protect AI, which is a platform for AI security. I've got about 10 years of professional hacking experience, and then about 4 years ago, I kind of saw the AI juggernaut coming and was like, I got to get in on this, and so I started studying machine learning engineering. And I thought I'd have to leave the whole hacking career behind because there wasn't such thing as AI security at that point in time. But thankfully, this company scooped me up and said, no, you can combine the two, and this is, I think I was one of the first few people in that could be labeled as having an AI security job specifically. And I'm very grateful for them for that. I also help design and run Hunter.com, which is an AI ML specific bug bounty program. And this gives me a really unique view into the kind of holistic view of what AI security is, because I get to see these vulnerabilities come in live in real time and see them all before anybody else on planet Earth gets to see them. I think I've seen several hundred reports now at this point. And so I have a pretty good grasp about where it is now, where it is going in the future, and where people's misconceptions lie right now. So the whole purpose of this talk is to answer this question: what are the practical attacks against AI today? Not theoretical. I'm a little irritated with a lot of the academic research papers coming out in this space because I feel like a lot of them are just journalist bait. If they're not coming out with GitHub code or a product along with the release of the academic paper that says, all these models are vulnerable to something or other, some algorithmic attack, then I can be pretty sure that it's not going to be a very practical attack. So if you don't pay attention to anything else in this presentation, these next 2 slides will give you a better overview of AI security than 99% of planet Earth. You can kind of think of it categorically in these 3 sections. You've got supply chain, model files, and model inputs. Now, if I had to poll everybody here and ask them what is AI security, you'd probably say ChatGPT jailbreaks and ChatGPT, input things that make it spit out weird data or something. That is absolutely a valid concern. It is not necessarily the most practical way of hacking AI in the way it's deployed today. So first, we've got supply chain. Supply chain, kind of a confusing word because people think it means the chips from China, they have malware on them. That's supply chain. When I say supply chain, I mean the open source libraries you use to build and deploy AI models. That's mostly libraries on GitHub. That's going to be PyTorch. That's going to be XGBoost. That's going to be MLflow. Anything you use to build the model and then share the model with the world is what the supply chain is. It's not like the actual chips that get shipped over. Model files themselves are another category of AI security because model files are just programmatic objects that are stored to disk. There's nothing mystical about AI models. It's just an object that you take from memory and you store it to your disk. So now you can email it out and share it with the world. However, there's an issue with those that I'll get into on the next slide. And last, there's the model inputs. That's like ChatGPT jailbreaks. That's tricking a model into thinking a hot dog is a wiener dog or something like that. That's model input security. And that's where a lot of the focus has been, especially from the media, about what AI security is. But take a look at this. From all the research I've been doing, this is sort of the pyramid of disaster for AI. At the very bottom, we have model inputs. Model input attacks, from a hacker's perspective, from someone who's trying to break into an organization, are not that practical at this moment in time. And the reason is, think about if you're a Russian threat actor. Are you gonna go, and you're attacking OpenAI, are you gonna go to ChatGPT and try and get ChatGPT for 3 months to spit out OpenAI employee passwords? Like, probably not. There's much easier paths to break into their AI supply chain or their AI engineering department than like going through the actual model inputs and outputs. So that's why we've got the model input attacks fairly low down there on the actual practical skill from a hacker's perspective. Next up is model file attacks. These are actually much more practical. The reason being, for the most of the time that the AI engineering community has existed, they've been storing models in terms of pickle files. Thank you. Pickle files are a way of just storing programmatic objects to the disk so you can share them around. But pickle has a problem, and pickle can have remote code execution. I'm sorry, deserialization code execution attacks. What that means is if you send a pickle file to somebody else and they load that file and it has malicious code in it, they've executed that code. That is an extremely practical attack. Think about phishing emails. Like, these are amazing phishing email attacks. You send them an email that says, hey, I'm seeing a bug in this model. Can you check it out? And they're like, yeah, sure, I'll help you out. They load it, boom, code execution. Not only that, antiviruses don't catch them. And I'll show you in a little bit. Actually, maybe I can show you now. I did some research onto what antiviruses actually detected model files as being dangerous code execution files. None of them got even the most basic malicious code embedded in an AI model file. Microsoft Defender, for instance, didn't catch the basic Python reverse shell or the Python reverse shell, which was base64 encoded, a slight obfuscation. It did catch the Meterpreter reverse shell, and that was the gimme. I threw that in there in my testing just because Meterpreter's been around for 20 years. Every antivirus should just see the string Meterpreter and then flag on it. And thankfully, they do. But they don't on every other basic attack that you can use on a model pickle file. So there's like safer ways of saving models. There's Onyx, there's various file formats that don't execute code when you load them up. And so we're trying to get the industry to move into those, but we also have an open source tool called Model Scan, which is really, really useful at scanning model files for these kinds of malicious attacks that antiviruses just don't even detect. And last, we have the bear in the room is the supply chain. This is where we're seeing every kind of practical attack take place. Why is that? Because the model file itself is not really that useful unless you share it with people or give it some kind of access so other people can use it. Otherwise, you just have a file sitting on your computer. So anytime you stand up a web server to serve the model to a broader audience, like your internal company or the public at large, you're opening up your attack vectors just exponentially. So an example of this would be like ChatGPT. They have the model file somewhere in the back end. They have a website. That website's part of the supply chain. If you can get API attacks against that website, you might be able to steal the model file itself through the web server that's serving the model. Getting the model itself to serve itself, like tricking ChatGPT into saying, hey, send me your model file, it's not going to happen. From a practical attacker's perspective, you're going to get in through API attacks. And it's actually kind of interesting because I find a lot of parallels with mobile application security when it first came out. You've got different tools. You've got a different kind of file output. You've got an APK file. And in this case, we have a model file. And then you also have slightly different attack paths like P-lists. P-list files are a part of some mobile applications, and they might leak some sensitive data. And in AI, you have model inputs. You might be able to trick it from thinking a hot dog's a wiener dog. Not really that impactful, but the API security when mobile apps came out was crazy. It was like everyone just got amnesia and forgot what API security was. I remember Pizza Hut had an application. You download Pizza Hut's application, you can buy pizzas on it. The problem was you could intercept the responses from the server and change paid from true to false or false to true and get a free pizza. Like, that's basic API web security. That's just the absolute most basic attack you can do. And that's what was happening back then. And that's what's happening now in AI. These API attacks are extremely practical, and they are everywhere in the industry. In terms of like total overall security, I've got the AI industry basically on the bottom of like all the software engineering projects you can do. So if you're just like building a chat bot or something, or let's just say like a basic web application to serve, selling your widgets, it's really easy to use a framework like Django and make a website that has built-in security. Like you don't even have to worry or think about it. But the AI field doesn't have that. Everyone's building everything from scratch, and API security is a complicated business. So these people who don't have API security backgrounds are building all these AI tools, and it's causing a lot of problems. And I'll show you what practical vulnerabilities I've seen in just a second. Obviously, the source of this is just speed of development and convenience. If you're first to market, then you automatically gain a certain number of users that your opponents are not going to have. You also want it to be very easy to use, and that convenience is also a big problem because it means you want to be able to load files from S3 buckets. You want to be able to load data from the file system or a network file share. Very convenient. Opens up a can of worms when you're talking about security, though. And obviously, where this kind of manifests itself is there's a lack of authentication. It's just not there in like most of these AI tools that deploy models. Overly permissive read-write on the file system is probably the #1 biggest issue. Here's the thing, with a normal website, most of the time the only files they're handling are gonna be like profile images. You upload a profile image, it saves it to an AWS, that's it. AI is all about the file system. It's all about files. The data's a file, it might exist in S3 bucket, it might exist on your local system, whatever. Their model is a file, you've gotta be able to save the model somewhere to disk, you've gotta be able to upload remotely, that kind of thing. This is where we're seeing the biggest problems. And these are the actual specific vulnerabilities that I've been seeing in the AI sphere as a whole. Local file include is probably the most common. For anyone who doesn't know, local file include is basically the ability to read any file on the server. So let's say you stand up a web server that serves ChatGPT, and you go to chatgpt.com, file equals user.passwords. I can just read those files off the server. That's everywhere. We keep seeing it over and over and over. These file system permission issues. Server-side request forgery, same thing. You need to be able to read stuff from remote locations. So S3 buckets, network file systems. So what if you just you put it in the website, my data is stored at S3.whatever. Well, what if you just turn that to say, my data is stored on localhost at port 5000. Now you can get internal network data. Arbitrary file overwrite, again, more file system issues. They're just not checking for putting permissions in place for where you can save the file. So you upload your data, it makes you a model, and you go, I want to export that data now. You can just specify wherever you want to put it. I want to overwrite the SSH keys. That's available. And I'll show you a couple examples of that. And remote code execution is obviously the holy grail of vulnerabilities. That just lets you completely control a server. That is also, sadly, very common. Deserialization attacks, that's the pickle file. You load a pickle file. Let's say you stand up a web server and you allow users to upload their own model so they can store it somewhere, but you allow them to upload pickle files. Well, now you've opened up remote code execution on your internal network. It's crazy. This is probably the most common vulnerable call that exists in all the AI tools I've seen. Get artifact. In the AI world, artifact just means file, so this is just the call that says get file. And every time I see this thing, there's a vulnerability. So these are a handful of tools that are used commonly in the AI sphere. MLflow, Kubeflow, ModelDB. GitHub even had this issue a few years ago. Those top 3 are all from our bug bounty program, but GitHub was from a few years ago, and I just added it in here because this get artifact call is vulnerable across the globe for some reason. All right, so let's go to the real world examples. Enough of the theory. I love this XKCD because it's so accurate. In movies, hacking is, I got into the firewall, I've hacked the firewall, zoom enhance, that kind of thing. That doesn't happen. I haven't hacked a firewall in my 10 years of being a professional hacker. You don't have to. You bypass the firewall. In real life, a hacker's just gonna download a password list and then just spray the passwords against your company's email addresses. One of them's gonna hit. Or they type in summer 2012, summer 2024, and they just, 1 out of 200 employees is going to use that as a password because you have to cycle your passwords 4 times a year. So they're like, oh, I have to do this again. In real world AI hacking, the equivalent of this would be all these academic papers that say, algorithmic attack says if you take the square root of the base of this and then give it to the model, then you can get the model to think, jailbreak the model or something. Or, have the model think that the housing prices are going to go down when actually they're going to go up. Those are fine. Those are things to think about. But in the real world, A hacker's going to go, oh, hey, look, they exposed an MLflow server publicly on the internet. I searched Shodan, I see it, and now I'm going to use a local file include to download the SSH keys, which now lets me log in remotely to the MLflow server and spray those SSH keys across their internal network. Now I have access to 30 different computers, as well as all your models and your data. So let's talk about MLflow. MLflow is a model repository. It's kind of the de facto way of storing your models in the AI world. It's a place where you keep your models, you do versioning of the models. It's just like GitHub, but for models. And so one day, when I first started to protect AI, I go and talk to one of my really skilled machine learning engineer counterparts. And I'm like, Chris, if there was one tool that if you could breach it would be like catastrophic, you know, what holds the keys to the kingdom? He's like, that's probably MLflow. So I go home and I boot this up. MLflow is very simple. You just do pip install MLflow and then type MLflow UI. Starts up a web server. Now you can use the web server to upload your models, do versioning and stuff like that. That's what the web server looks like. And immediately, 1,200 of these servers right now publicly available, just to that point. There's even 4 in Iran. Like, man. So I start doing some research on this. And I find that there is a problem because I see right there, it says artifact location file : //. As a hacker, anytime I see file : //, I know there's going to be a problem here. There's going to be some kind of vulnerability. And in fact, there was. So what you do is you tell MLflow, I want you to store the models in this folder. And in this case, I want to store the models in .ssh. That's where my SSH keys are. Then you go to, and you make a get artifact call. There's the get artifact again. And you say, I'd like to get an artifact, and that artifact's name is going to be ID_RSA. That's my private SSH keys. MLflow happily spits this out. Now, what you have to understand is that MLflow has 10 to 15 million downloads a month. I'm certain if you're not in the AI industry, you probably haven't heard of it. If you are, you've definitely heard of it. Fortune 500s use MLflow. It's very common. So this presents a problem because there's also no authentication on MLflow. So at the time of this research, there's 1,000 publicly available servers that at any point, I can just go say, give me all your models, give me all your data, give me all your passwords, with nothing in between me and all of that data. That's how someone's going to steal OpenAI's model. You know, they're not going to use ChatGPT. They're going to go straight through MLflow. So that was the first AI vulnerability I found, 0 day. There was 10 more to come. I'll share a couple of them. And when I wrote this, when I found this vulnerability, I wrote a blog post saying MLflow has an LFI. You know, everyone should update. And we had MLflow in the bug bounty program, and very shortly after, someone posts another LFI in MLflow. Exact same location. It's a patch bypass. This is what it looks like. Instead of just doing file : //, you know, SSH folder, he just puts a little dot in there. Dot, now /SSH. Same thing. Now, since this has come out about, 8 months ago, there's been like 10 LFIs in MLflow. So there's 1,200 servers out there that are just, they've been vulnerable pretty much since they came out. This is a really hard problem, and I don't want to blame the MLflow developers in any way, shape, or form. They take this stuff really serious. They fix it as fast as they can, but I don't think necessarily the people that are developing all these AI tools are coming from secure API backgrounds because they've been in AI their whole life. Like, there's not a lot of crossover between the AI industry and AI engineers and system administrators or, network administrators. Like, you kind of just stay in that lane, and you've been there for a long time. So they're building tools from scratch without a background in API security, which, as you can see, gets a little hairy. So that brings me to my next project. This was the next CVE I found. I've got 11 0 days in AI tools so far. This is H2O. H2O is another thing. It's an ML ops tool. You stand it up, you feed it data, and it just trains a model for you. You don't have to know nothing about AI or machine learning or anything. This just does it all for you. You just feed it data. Stands up a web server, no authentication, exposed to the entire network, meaning if you pop this up on your home Wi-Fi, everyone else on the home Wi-Fi can hit this server and perform any exploitations that they want. So I start with the logical place, which is upload data, because that's what it's supposed to do. You upload data, and then it makes you a model. That's pretty cool. Like, it works really well. That's finding number one. So I found out as I typed into where I wanted to import, the file I wanted to import, it fills out a list of files from the server, not from my computer, but from the H2O server. So I can see everything. I'm like, okay, well, that's pretty useful if I have another vulnerability, which of course I do. This was 10 minutes to 3 CVEs. So I upload my SSH keys from the server. I actually didn't upload anything. I just asked it to go fetch the SSH keys from the H2O server, and it happily spits it out. So we've got unauthenticated LFI again on a tool that's exposed to the entire network by default. And now I'm like, okay, well, that's 2 CVEs. What do I do with this data now? Can I download it? Yes, you can. And there's also a check mark here that's very handy that says overwrite. That means I can overwrite anything on disk. I can overwrite the SSH keys and then log in remotely with my personal SSH keys without a password. So I mean, this was 10 minutes and I just gave up. Like at this point, I'm like, I'm just gonna let everybody else figure out the other low-hanging fruit. H2O is a very popular framework. If you Google AutoML, that's automatic machine learning, it's always in the list of the most popular ones. AutoML, Google has AutoML, H2O, AutoSKLearn, all of these are popular frameworks. So this is quite popular. But that was a really quick little research. Now let's talk about what happens to the big boys. We've got NVIDIA here. NVIDIA wrote Triton Inference Server. Now to give you a little background, an inference server is just any server that takes data and feeds it to a model and then spits its output back to the user. So this is like what's deployed on the edge. You train a model, and in order to give it out to the public or the internal network, you put an inference server in front of it. Usually a web server or an API server in this case. There's no front-end website for Triton. It just stands up an API server, you send it requests, it sends you back data. That makes this a very juicy target because this is what's supposed to be deployed at the edge. This is what users are supposed to interact with, what you're supposed to publicly expose. They say it's production ready, and it is probably the de facto standard of inference servers. This is what every major cloud provider provides documentation or just an automated solution to use Triton Inference Server as your inference server. Now, someone came to the bug bounty and said, hey, I found an arbitrary file overwrite. They did exactly what I was talking about before. They just captured all the requests between the inference server, between their browser and the inference server, did a control F for file : //. They find it, and they changed the file path from the legit location that Triton was trying to save files to an arbitrary location, and it worked. You can just create any file you want. You can overwrite any file you want. And we're like, oh, that's pretty cool. But the fun part of my job is when I get these kind of vulnerability reports and I go, how far can we take this? Because arbitrary file overwrite isn't direct remote code execution. It takes user interaction. As a hacker, I hate user interaction. I want to get this thing done now. I want to execute commands on that remote server and take it over immediately. So me and Marcello Salvati, the other threat researcher at Protect AI, start doing some research. And we figure out that you can actually do some crazy shenanigans with the backend parser that Triton uses that you can change remotely. So you can change it to say, hey, I just want to upload direct code, Python code, instead of these model file formats, which gives you direct remote code execution through this vulnerability. However, we didn't realize there's actually a much easier way of doing this because Triton came back to us after we reported this vulnerability, and they were like, no, that's totally normal. You can only do this when you add an argument to Triton and you say model mode explicit. That means you can hot swap your models. That means Triton server's running, and you can tell it, hey, I don't want to use this model anymore. I want to use a different model. And they're like, yeah, that's just how it works. And we're like, I still feel like that's a vulnerability. That's remote code execution in a function that doesn't have anything to do with executing code. It's just supposed to allow you to upload a new model. So this affects even Fortune 10 companies. These kinds of file permission issues are just endemic to the entire industry. And the last example for the big boys, this is Ray. Ray, again, is a very similar service in that it stands up a web server and you interact with it to do stuff like cluster a bunch of machines together to train a model. Now, who needs to cluster a whole ton of computers together to train a model except for large organizations with massive amounts of data? So again, this is a wonderful target. So my buddy Sierra, texts me one day, and he's like, hey, what should I focus on in the bug bounty? I'd like to get some money. And I'm like, well, there's this project Ray. It stands up a web server, similar to the other ones we've seen. I think that this is probably a good target because no one has reported any vulnerabilities whatsoever. And so both of us, get on the phone, and we spend 30 minutes just poking around Ray. Ray's very easy to use. You just type in pip install Ray, and then Ray start. There it is. Now you have a web server. It's running. 30,000 GitHub stars. It's actually so predominant. If you go to Google Vertex AI, which is Google's cloud offering, it is right here. It's just on the home screen of Google Vertex. It's extremely popular. So we look at it, and after 30 minutes, we had 2 remote code executions and I think a couple local file includes. So we're like, man, that's insane for a product that is like Google deploys by default on their cloud offerings. Ray, however, had a curious response. Here's what they say. Thank you for investigating any security concerns. In this particular case, from the position this query is being run, the caller would also be able to submit and run arbitrary code for execution. And I'm sitting here thinking, but doesn't that mean we don't need to use the vulnerability we found? You can just run code, and you're saying that's a feature in this tool that has no authentication at all? And also, P.S., we fixed it. Okay. And so Sierra comments back, but wait. This can be run from anyone on the network anonymously, no authentication, and it allows you to control the server. You own the server, the models, the data, everything, like the SSH keys. And Ray responds, Ray at its core provides arbitrary code execution for blah, blah, blah. Let me just summarize this. He says that this is a behavior that Ray is supposed to do. That's a feature. It's not a vulnerability. Second, Ray is secure because it runs on localhost. It's not exposed to the network by default. And then last, of course, he says, well, you can change the configuration so that it is exposed to the network, but obviously that'd be dangerous. There's a lot to unpack in this answer. Let's start with the localhost. Ray says it's secure because it runs on localhost. What that means is if you run Ray by default, you're the only person that can see the web server. Someone scans the network, they don't see a Ray web server. If it was exposed to the network, then yeah, someone on your local Wi-Fi could hit it. The problem is twofold. One, if anybody else logs into the server that's running Ray, they can use Ray for privilege escalation because now you get the permissions of the user that started Ray. Other people on the same server can reach localhost web servers. The second reason is called a JavaScript drive-by attack. This is what it looks like. This is where a malicious person hosts this HTML on a website, and they send you the link. And you click that link, and now you have just gotten remote code executed. They own your server in one click. What happens is, when you visit the website tells them to send a request from the user's browser to localhost, exploiting this remote code execution. So it's a one-click RCE, and this is why localhost is not that secure. You can fix this with things like CSRF tokens, but they didn't have CSRF tokens either. And so we brought this back to them, and they wanted to dispute it some more. But then briefly after we got into this discussion with them, and like a bit of an argument, Bishop Fox, which is another pen testing company, comes out and says, hey, we found a bunch of CVEs in Ray. It's the exact same ones that you guys found. And that was when they're like, all right, whatever. We'll try and fix this. So this brought us to bring up, me and Marcello wanted to figure out how to send these exploits to red teamers. How can hackers use this easily? Because it's just like these vulnerabilities are everywhere and they're really easy to find. It just doesn't take much effort. An automated scan of Ray using Burp Suite is what found me the first LFI. That means this tool has never been scanned, but it's 30,000 GitHub stars. Millions of people have used this tool. I don't know if it's millions, maybe I'm exaggerating, but in the AI world, a huge percentage have used this tool, and it hasn't even been scanned by an automated security scanner. So we created this GitHub repo called AI Exploits. It's got Metasploit modules for all of these vulnerabilities. That means you can just run, I can actually show you. You just download this repo. How are there ads on this? You just you download the repo, you install the Docker image, which is very, very easy. It's just 3 commands. Right here, those 3 commands starts up Docker, which also starts up Metasploit. So you don't even have to have Metasploit installed or anything like this. And then it'll just you could just load the modules, which are already included in the Docker. And so in this case, he is setting up the Ray exploit. He sets the remote host, the server running Ray. And then he just hits enter. And as soon as he hits enter, you can see a shell was returned. So this is total control over the server, get UID, it's Ray. No authentication, no nothing. Just point and click exploitation of this incredibly popular tool. Now, what this looks like if you didn't want to use Metasploit, take a look at this. This is my Ray cluster. I have a Ray cluster set up right now. It's running on my laptop. If you scroll down to this little CPU flame graph link, it brings you here. It says failed to execute a command. And then at the very bottom, it helpfully instructs, maybe if you ran this as root with total admin permissions, that would fix this issue. I'm like, that's very helpful. However, if you just add this right here, it says format, for those who can't see it, because I don't think I can zoom in on the URL, it says format equals touch/temp/protect AI. I just added a command into the URL, and it runs that command. Again, no authentication whatsoever. And so if I run this, hit enter, it should have created protect AI in my, yep, there it is. It creates the file right there. So just that's a proof of concept. I mean, this is the state of AI security right now. These are the popular tools. These are not like small projects. This is backed by a large organization. And this is not unique to Ray. So part of the AI exploits, we also include vulnerability scanners. So in case you don't actually want to exploit your own network, you can just scan for the vulnerability. In this case, they're called nuclei templates. You just, you run the Docker image like I showed you before, and then you just type nuclei-t for the template name. In this case, it's going to be Ray CPU profile command injection.yaml, and then the target, -u, localhost, and the port. And if we run that, then it checks, is it vulnerable? Takes its time. There, HTTP critical. So this is how you can test your own organizations for if they're vulnerable to any of the exploits that are in our public repo. Now what's kind of weird is that Nessus and Nexpose are two big vulnerability scanners. They actually don't find, I think, any of these vulnerabilities. They've been out for months, but they don't have a plugin for them. I'm not sure if that's changed recently, but as of like a couple months ago, didn't find any of these. Didn't even fingerprint these servers as being MLflow servers. They just see there's a web server, that's it. So we also included some Nmap scripts in the repo. Nmap is a network mapping script. It lets you just scan every computer you can see, and it'll tell you if there's any AI tools that are being run on that server. So let's look at a realistic attack scenario of someone using Ray. Attacker searches LinkedIn for your company. They search AI engineer or ML engineer at your company. They find a list of names, and then they go they find the domain that your emails are hosted on. Then they use the harvester to collect all the valid email addresses from these people. The harvester is a tool that scrapes the internet for valid email addresses given a domain name. So this will search for everybody that works at OpenAI. OpenAI.com, it'll just give you a list of like 20, 30 email addresses. Send all of those ML engineers an email. And in that you say, hey, I'm a new hire. I have an issue with some of the documentation. Can you take a look at this documentation? And you send them a link. Of course, on that link, you're hosting the Ray CSRF proof of concept that I showed you earlier, just the HTML that forces their browser to execute remote code. And then Ray guy says, yeah, I'll be helpful. I'll click that link. As soon as they click that link, you are now an OpenAI ML engineer. Congratulations. You can now spread throughout the networks, pick up their SSH keys because you already have total control of their server, and spray them across the network. Now you have access to tons of different servers. And the thing is, ML engineers have very high permissions in general in large organizations. The reason is because they have to collect all this data from all around the network in order to be able to do their job. They're given lots of permission to install these small tools that are just their personal preference because it's not really, the tooling in AI is not really like conglomerated yet. Like everyone uses Google for search, but everyone uses something different for the small parts like hyperparameter optimization of their models, things like that. But this is a very practical external attacker to your internal network. And the reason this is so practical is because you bypass the firewall. Again, I've never hacked a firewall. I've done something like this on all of my engagements. So a lot of people will say, yeah, but it's on the internal network. It's protected by the corporate firewall. It's running on localhost. Nobody can get in. And I'm like, you click one link. I am now you. That's not a security boundary. The firewall and localhost is not a security boundary. They help, but they're not going to protect you from, JavaScript drive-bys. And if you're on the internal network, again, the vulnerability scanners don't find anything. Nessus doesn't find anything. So just go download our Nmap script or do an Nmap scan of the whole network and then just Control F for MLflow, Ray, whatever these tools are. And then you can just run the exploit from your laptop to get access. So having seen all of these vulnerabilities in the AI sphere and looking at them from a practical hacking perspective, I have some insight into where I think the future is going in AI security. Take a look at this. This is XGBoost. XGBoost is a popular library for training machine learning models. You say model equals XGB classifier, then you train the model, and then in order to get predictions out of the model, to actually use the model to predict housing prices or ad analytics, you type in model.predict and the data that you want to make a prediction on. What if somebody found a bug in that predict function? This is what it looks like. It's C. So it should be it could be vulnerable to buffer overflows, all those like various memory corruption bugs that C is vulnerable to. If you found a bug in this, every single XGBoost model in existence at that moment in time is vulnerable to user input causing remote code execution or denial of service because that .predict function is solely meant to take user input. If you're going to use a model, you have to use the .predict function. You know, Triton inference server's right here. The user's over here, the user sends data. Triton sends it to the model uses .predict, and then sends data back. Like, that's how you use a model. This would make every model that's ever been trained with XGBoost vulnerable to possibly remote code execution at worst. But now I'm gonna take off my hat of being like, you know, professional and start speculating. This is just my personal opinions. I speak for nobody but myself. Where is this going? One thing I wanna say is that I think that even though I said the model inputs right now are the least practical attack in AI, jailbreaks and stuff, like, yeah, they work, but are you gonna, you know, take over a network with them? No. I think that's gonna change in the coming years. And the reason is model agency. Model agency means ChatGPT now has the ability to run commands on the back end. Once that starts happening, which it's happening right now, the AWS has some agency models. AutoGPT is like giving ChatGPT agency. It can go run commands, get output, run some more commands. That's when it starts getting more practical. But on a like more societal level, that's where I see the near future, is model input attacks with agency starting to become kind of bad. But on like a societal level, and this is where the speculation really comes in, these LLMs and generative AI in general took over the creative industry first. They hit the creative industry first, which is crazy to me because you'd think human creativity is the last bastion that we'll have against the machines, and yet that was the first one that gets hit. What is next? What is next? I think a lot of people will say, oh, accountants, you know. Accountants are gonna get hit next because they're just taking a bunch of data in a database or a spreadsheet like Excel and then transforming it into a different database or spreadsheet. Like, that's what machines are really good at. I don't think that's the case. I think the next one coming is programmers. I think we're all screwed. Devin was recently introduced. Devin is supposed to be this, I guess it's like an LLM with agency. You tell it, build me a website. I want the following criteria. It goes out and it builds that website and hands you an application at the end of it, which is kind of insane. But what this really means in the future is that the dominoes fall. Once you have programmers, once you have LLMs that can program effectively, all the other careers start falling like dominoes. Because software has been eating the world for 50 years now. Now if you have an LLM that can program as good, at least as good, as the average human programmer, well, and that's when the accountants fall, and the doctors, and the lawyers, and everybody else, because those LLMs are just gonna be on this infinite loop of writing, doing tasks that all these other people were doing manually. Those 10 years of medical school, half these LLMs already beat the medical exam. They beat the SAT, they beat the bar. So that's where I see the biggest issue in the future of AI security in terms of like a societal level and not these like specific CVEs and vulnerabilities and stuff, is once the programmers fall, everybody else kind of falls with them. What? They've been hit. I guess we'll say, like the creative industry's been hit. I wouldn't say they've fallen, because there's still creative jobs. Programming has been hit already. Half my code's written by ChatGPT. Like, this is very obvious. I think once we get Devin to version 3, that's when it affects, as soon as it's as good as 95% of programmers, that's when the exponential curve starts taking off on the asymptote. Like, things start to fall over. And that's probably not gonna, I mean, that's with within our lifetime for sure. But that's, I'll put on my professional hat again. That's just my crazy speculation. But that's where I wanted to end it. That's kind of my overhead view of AI security as a whole. Are there any questions? Yes.
Are you recording? Oh, you're recording. Oh. For what I saw, great talk. I'm curious if you've seen, and I actually don't know, have you seen any persona to persona integration? So, I have LLM1, LLM2 now going back and forth, trying to determine accuracy of code so that you actually exponentially begin to increase that asymptote.
Yeah, we've written some scripts that do that. So we're writing some tools that try and find vulnerabilities in code. And what you can do is have one LLM judge the output of the other LLM and say, I'm not really sure this code actually has that vulnerability. Maybe if you tried this, and you feed that into the other LLM. So yeah, it's this infinite spiral of just artificial intelligence talking to each other. Any other questions? Yes.
You mentioned the coming of age, really, of AI around security, right? So Copilot's being released a little over a week, right, around security. How do you see that impacting a lot of these vulnerabilities, or is that more around traditional cybersecurity, looking for threat vectors?
It'll for sure affect it. We've been looking for ways to automate these bug bounty programs for a while, and one of the things we're doing is building an LLM, just like the GitHub Copilot, that finds vulnerabilities in code. Surprisingly, they're rather effective today. Like today, I can go feed it the Triton code that was vulnerable to the file overwrite, and it finds it. Like that was a 0 day not too long ago. So yeah, I think like the total overall security of code in general will definitely go up as that process is automated. So that as soon as you put something up to GitHub, it's automatically scanned for vulnerabilities. For sure, that's going to affect it. That kind of just leaves the creative attacks. And I don't know. I guess that answers your question is, yeah, it's going to affect these a lot. We're going to stop seeing this sudden influx of 0 days when those tools start getting deployed more and more broadly.
So you mentioned how, a lot of these ML developers, that they don't have maybe the best security practices in mind, right? So they create a lot of these vulnerabilities, and you said web designers, or there's a lot of frameworks out there like Django you gave in his example.
Yeah.
But it seems like, for a lot of these applications, really, it is just like a web interface, wrapped around their IP, right?
Yep.
So are there any frameworks out there that you see companies using, or that kind of cater to this audience, or do you suggest they just learn Django? Do you have any suggestions there?
Yeah, I mean, honestly, using the well-known web frameworks is a good idea. Like Django is pretty secure. Laravel, pretty secure. It is a good idea to do that. I'm sure that'll happen in the future. I see that being another several years out, though, because a lot of these functionalities are specific to AI and machine learning. Like the whole idea of all this file system access is not something that's in a traditional Django app. So I'm imagining you would have to write some plugins or something, some safety plugins in Django to account for the uniqueness of inference servers and the file system access and general convenience. But yeah, I mean, that would be my recommendation for sure. Use libraries that are already well known. But again, the people that are building these tools, most of the time you build something that was useful to you, and then you share it with your coworkers, and then the coworkers are like, oh, this is really cool, so you publish it, and suddenly it becomes 4,000 GitHub stars, and now it becomes a company, or somebody buys it. So it tends to be just like passion projects that spun out of control for a lot of these projects. We're not seeing a ton of development from like Google to go have a standardized model repository, because how do you compete with model deep MLflow when it's been out for so long and it's already got so much market share? Any other questions? All right. Thank you very much.
Thank you, Dan.